Okay. Yesterday in class, I showed you guys the unit circle where the radius length is always 1. And we talked about where the unit circle intersects at 30, 45, and 60 degrees. And then we talked, okay, now that I know that coordinate, now I know the x coordinate is going to be the cosine of that angle. And the y coordinate will be the sine of that angle. So for instance, for 30 degrees, we knew it intersected at radical 3/2 and 1/2. So if anybody asked, hey, what's the cosine of 30? I don't have to go to my calculator anymore. I can just say, oh, cosine of 30 is radical 3/2 because cosine is represented by the x coordinate, and the x coordinate at 30 is radical 3/2. Now what I want to do is take these degrees here and move it to the second, third, and fourth quadrant, but still talk about sine and cosine. Before I can do that, though, we need to make sure that we understand if sine is positive or negative in quadrants 2, 3, and 4. And the way to do that here is we're going to set up and fill in this table right now. We're in quadrant 1, 2, 3, and 4, and I want to know from you guys, is sine positive in those quadrants? And is cosine positive or negative in those quadrants? And the way we can do that is we can go around real quickly on the unit circle, all right, and say, all right, we know the sine is my y values, and the cosines are my x values. So as I go around here, let's start with sine. What do I know about the y values in quadrant 2? Or excuse me, let's start in quadrant 1. What do I know about the y values in quadrant 1? They're all positive. What do I know about the y values in quadrant 2? They're also all positive. Now when I go to quadrants 3 and 4, what do you notice about the y values? They're all negative. Now let's do the same thing for cosine, but now we're looking at what the x coordinate does. So we're in the first quadrant, and I know the x coordinates are positive. When I'm in the second quadrant, though, it changes to being negative, the x coordinates. And then in quadrant 3, it still remains negative. And then when I move to quadrant 4, my x values go back to being positive. So this is where sine and cosine are positive and negative in every quadrant. Now that's a lot to remember. For instance, noticing sine is positive in the first and the second, and cosine is positive in the first and the fourth. I'm not going to have you guys remember that because I have a device that will help you remember that. And that is the following. A, S, T, C. What's all that mean? Well, how do I remember where the AS and the TC go? I remember one phrase and one phrase only. All students take classes. So again, all students take classes. That reminds me where the ASTC go. Now, what do they all mean? The A represents all, the word all, meaning all these functions, sine and cosine, are positive in the first quadrant. So the A stands for all. All are positive in the first quadrant. The S in quadrant 2, I'm sure you can guess, stands for sine. Only sine is positive in quadrant 2, nothing else. As I go down to quadrant 3, there's a T for tangent. And I know we've only talked about tangent for SOHCAHTOA, but next week in class, we'll dedicate a whole day to tangent. But for now, just remember that tangent is positive in the third quadrant and nothing else. And then finally, the C in the fourth quadrant is for cosine, meaning only cosine is positive in the fourth quadrant, nothing else. So that's how I remember where everything is positive and where everything is negative, using the phrase, all students take classes. Now that's what we're going to do here in problems 1 through 10. We're going to go through each of them. We're going to name the quadrant they're in. And then based on the quadrant and the function, sine or cosine, without using our calculator, we're going to be able to tell if it's positive or negative. All right, so let's go to the first one, the sine of 57. Well, 57 is in quadrant 1. And in quadrant 1, all are positive. That's what that A represents. All are positive in quadrant 1. So I know sine would be positive in quadrant 1. In quadrant 2, in number 2, 117, that would be in quadrant 2, and we're dealing with cosine. And in quadrant 2, there's an S, meaning sine's only positive. In quadrant 2, meaning cosine is negative. Let's go to negative 87 degrees. Now be careful, we're going in a clockwise direction, which means negative 87 would be in quadrant 4. Now let's take a look. What do we know in quadrant 4? Only cosine is positive. So that would mean sine would be negative. Now take a couple minutes. You guys on your own in your groups, go through 4 through 10. Pause the video right now. When you replay it, I'll have my answers up here as well. So go ahead, finish it within your group. Just finish up through 10. Okay, so that's what I have for the rest of them. I'm hoping the ones that were in radians you didn't need to convert those because we knew pi over 6 was 30 degrees. For number 7, we know pi over 3 is 60 degrees, so I multiplied that by 2 and got negative 120. And then over here in number 9, pi over 4, remember, is 45 times 3 gave me 135 degrees, which is in quadrant 2. Okay, so hopefully everything matched up. If they did not match up, please change them now. Okay, moving on now. Similar exercise, but a little different information I gave you. Still name the quadrant I'm in now. Where could I be if I was given this information? So 11 says the cosine of the angle is greater than 0 and the sine is less than 0. What one out of the 4 quadrants am I going to land in? Now, be careful here. Don't get confused and aggravated. Cosine greater than 0 just means cosine is positive. That's all that means when it's telling me it's greater than 0. And when sine is less than 0, it's telling me sine is negative. So go to your ASTC right now. Find the one and only one quadrant where cosine is positive and sine is negative at the same time this has to occur. All right. Well, quadrant 1 is out of the question because everything is positive there. So sine wouldn't be negative there. So where's the only other quadrant other than 1 where cosine is positive? And that would be quadrant 4. And sine is negative in that quadrant. Okay, so go to the next one now, number 12. Sine and cosine are both positive. Now I'm looking to happen at the same time. Don't take each one individually. So sine positive, cosine positive. Where are they both positive at the same exact time? And that only can happen in one place, and that's quadrant 1 where everything is positive. All right. Okay, now let's put it yesterday and today all into one. All right, and we're going to go back to the unit circle diagram. No calculators. I don't want you to stay away from the calculators. Go back to your unit circle diagram. All right, look at sine of 300 and say to yourself, okay, sine of 300, where did that intersect the unit circle? That intersected the unit circle at the same place where it had a reference angle of, what's the reference angle for 300 degrees? Think about it. Should have a reference angle of 60 degrees. And where did 60 intersect, where the unit circle intersects 60? We intersected 60 at 1/2 radical 3 over 2. Okay, radical 3 over 2. Now, take a look. I am looking for the sine of 300. And your work yesterday with me, what did you remember? Is the x or the y always the sine of the angle? The x coordinate or the y coordinate? Which one always represents the sine of an angle? It is the y coordinate, all right, the y coordinate. So the sine of 300 is equal to radical 3 over 2, because it's the y coordinate of 60 degrees. But be careful. Should it be positive or should it be negative? Well, if you remember from what we just did on the previous page, ASTC, 300 is in quadrant 4, and the only thing positive in quadrant 4 is cosine. So this should be negative. Negative radical 3 over 2. Okay? 1 doesn't make you great. If you feel uncomfortable right now, that's fine. We're going to get better at it right now. So let's do sine of 240 degrees. All right, so sine of 240. I know my reference angle is 240 minus 180, which would be 60 degrees. Okay, so 60 degrees, which again tells me I'm at 1/2 radical 3 over 2. I'm looking for the sine, so I'm going to pick off the y coordinate, which would be radical 3 over 2. Now I just got to remember, what quadrant is 240 in? 240 is in the third quadrant. And what do I know about sine in the third quadrant? It is negative because the t tells me only tangent is positive. So negative radical 3 over 2. Now, I'm doing this in this order, but you can start any way you want. If you wanted to start it by saying, is it positive or negative, and get that value, get that sign first, that's fine. All right, you can go in any order you want to get to negative radical 3 over 2. Okay, let's continue. Cosine of 210. All right, so I know the cosine of 210 will be the same as the reference angle of 210 minus 180, so that would be a reference angle of 30. And off the unit circle, 30 is radical 3 over 2, comma, 1/2. I'm looking for the cosine, all right, of 210. So I'm going to pick what value off, the x or the y? I'm going to pick the x value off. So the cosine of 210, pick the x value off, which is radical 3 over 2. Now I just got to remember if it's positive or negative. 210 is in quadrant 3. Only tangent is positive in quadrant 3, so cosine would be negative. A little pattern going on here. Let's see if we can break that right now. Ooh, cosine of negative 30. Okay, negative 30. So let's see, negative 30, if I graph that real quick, would be this angle right here. And my reference angle wouldn't be negative 30, it would be positive 30. So there's your reference angle, 30. So it would also intersect at radical 3 over 2, 1/2. I want which coordinate now? I'm dealing with cosine, so you want the x coordinate. So the cosine of negative 30 is going to be radical 3 over 2. I'm in the fourth quadrant. And what do I know about cosine in the fourth quadrant? It's positive, so my answer will remain positive. Radical 3 over 2. Okay? Moving on, one last piece, and then we'll be done, and you could start the assignment, is what's called the Pythagorean identity. It's very much like a squared, b squared, and c squared. We do not need the unit circle to do this, all right? What it's saying is the cosine of an angle squared plus the sine of an angle squared equals 1. Or commonly it's written sine squared theta plus cosine squared theta equals 1. Either way, I like using this one over the other one, and you'll see the advantages, hopefully, by the time we complete it. Okay, so take a look at exercise 3. An angle, and this is another gamma. That's another Greek symbol. Not particularly concerned that you know what the name of it is, but just, you know, it's like theta, it's like beta, it's an angle measure. Has a terminal area that falls in the second quadrant. All right, so we know this angle's in the second quadrant. And it is known that the sine is 3/5. Using the identity, determine the value of cosine gamma. All right, well, we're in quadrant 2, so answer should be, remember what we did today? Cosine's in quadrant 2, answer should be negative, because I know cosine is negative in quadrant 2. All right, now how do I find that negative answer? I go to my Pythagorean identity, cosine theta squared plus sine theta squared equals 1. I already know the value of sine. That's 3/5. So I plug in 3/5 for the sine of the angle. No, I don't put the sine with it because I already know the full value is 3/5. Squared equals 1. Cosine theta squared plus, okay, now I have an equation to solve. I'm going to square 3/5. In my calculator, go ahead and square 3/5. You get 9 over 25 equals 1. Move the 9 over 25 over by subtracting it. Cosine theta squared equals, go ahead, 1 minus 9 over 25. We end up with 16 over 25. Perfect. Now, how do you undo a squared? You take the square root of both sides, and the cosine of theta ends up being, taking the square root of that answer, we should end up with 4 over 5. But be careful. Yes, your calculator is going to give you positive 4 over 5, but we said we are in the second quadrant with cosine. My answer should be negative. Okay, negative 4 over 5. And finally, example 4, we're going to do the same thing now, except I think we're in a different quadrant and finding sine now, all right? So take a look. Theta now falls in the first quadrant. So I know my answer will be positive. The answer will be positive because everything is positive in the first quadrant. So now I go to my Pythagorean theorem. Cosine theta squared plus sine theta squared equals 1. I am given the value of cosine theta, so I plug that right in and square it. And now let's solve for sine theta. Okay, squaring 1/3, you get 1/9 plus sine theta squared equals 1. Move the 1/9 over. By subtracting it, you'll get 8/9. Taking the square root of both sides. Okay, now, all right, because it did say, take a look back at the directions, unfortunately, simplest radical form. And if I try to take the square root of 8 over 9 in my calculator, it'll give me a decimal. So let's go back to algebra last year and figure out what the heck do I do here. Okay, well, when you have the big square root, you can actually take the square root of each individual number and break it down into 2 smaller ones. And when I do that, you'll see on the bottom, at least, that becomes very quick, and that's just 3. On the top, I have radical 8, which you can break down. All right, you can break down radical 8 into 4 and 2. Square root of 4 is 2. Bring that radical 2 along for the ride, divided by 3. And we said at the very beginning, my answer should be positive because I am in quadrant 1. Okay, so now you can work on the assignment within your group. Please try it out. Don't leave it blank. Don't give up. You guys can do this, all right? I have a lot of faith in you. You're fine. Keep looking back at your notes if you need to. And we'll discuss any questions you have on Monday.